Okay. So let's take a look. Now, law of sines should be review for you from geometry. Yes?
No.
Law of sines does not ring a bell from geometry at all? All right, it might ring a bell once we actually start going over it. So let's do that maybe. So typically when we use trigonometry, right, trigonometry is based off of what kind of geometric shape? Right triangles, right? Very good. Not just triangles, but right triangles, right? So sine, cosine, tangent, and their reciprocals, cosecant, secant, and cotangent, all deal with relating an angle in a right triangle to a ratio of two sides of that right triangle, right? And then from that, we expanded it into the unit circle stuff, talking about inverse trig, all that jazz, but it's really just from that basic understanding and definition of sine relating an angle to the opposite leg over the hypotenuse of the right triangle. It's cosine and being adjacent, hypotenuse, tangent being opposite and adjacent kind of thing. Law of sines is a way for us to use trigonometry without having a right triangle. Okay, so let me show you what I mean. I'm going to draw a picture here, all right, of just kind of like a generic triangle. And I'm not going to put any right angles in it. Okay, we'll just draw a triangle here, and I'll call the vertex A, B, and C, like that. Okay, and then typically when you name sides, so we could use segments. We could say segment AB, segment AC, segment CB, but we could also name sides using the lowercase, corresponding lowercase letters. So lowercase a for opposite angle A there, lowercase c, opposite angle C, and then lowercase b for opposite angle B there. Okay, so we'll name things that way. Okay, without getting into the derivation of this, why it's true, we could do that. Okay, but I'm just gonna give you the formula here, the relationship. Okay, the way these things all relate is thusly: the sine of angle A over side A is going to be in the same ratio as the sine of angle B over side B, and the same ratio as sine of angle C over side C. You do remember it now? Yeah, okay. Yes, no, maybe soon. It was a while ago for some of you, yes. Okay. Or you can write it, of course, the reciprocal fashion, however you prefer, kind of thing. So either angle over side, angle over side, angle over side, or side over angle, side over angle, side over angle. Doesn't really matter there. Okay, is the idea. Okay. So let's solve here. Let's use this to help us solve for missing parts of our triangle. Okay. So first, we'll set up a directions here. So let's solve for the missing pieces of the triangle. Okay. Sometimes the directions are simply solve the triangle, which means come up with all the angles, come up with all the sides. Okay, and I'll draw a picture here. Okay, and we'll say there's C, there's A, there's B. Now let's say angle C is 97 degrees. Let's say angle A is 40 degrees. And let's say this is 22. Okay. Now, what kind of information are we given here about this triangle? What do we know? How many angles do we know? Two, but then really three then, right? We know two angles in a triangle. We know the third one because what can we do? Subtract them from 180, right? So 180 minus 40 minus 97. Okay, so let's see. That's going to be what? 140. What's that? 43? Yeah, I know. I'm trying to do it in my head too. 83. I got 43. It is 43. 43.
Oh, that's right. I wrote it as 48.
Which is 190 minus 47.
So 43, right, yes, exactly. So then we can say, aha, this angle must be 43 degrees. But even without knowing that 43-degree angle, knowing these two angles in this side, okay, you're going to have to like cast your memory back to geometry class, all right? This information right here, okay, is a triangle congruence theorem. It's what triangle congruence theorem? Angle side angle, which means... Were those shouts of excitement I heard?
Wait, we're not going to have to do that, are we?
Proofs? Oh, yeah, of course.
No.
Just kidding, we're not doing proofs. We're not doing proofs.
I
thought everyone loves proofs.
I
I want to drop out of class.
Sewer side. Sewer side, it's different. It's jumping down a manhole cover. Yeah,
Come on.
it's okay. Remike. Right, okay, how do we know it's angle side angle here? What gives it away, Julia?
Because it's an angle, and then the side is in between them. There's another.
So two angles and the sides between those two angles. So angle side angle, right? But because we can find that third missing angle, you could also technically call this an angle side as well, because you got an angle and the side is not between those two angles. Or angle and then this side, that way. So you could really call, every angle side angle is really also an angle side because of that. Because you have two angles, you can find the third one kind of thing. So it's pretty much, it's equivalent in a sense. Okay, now, that being said though, all right, a triangle congruence theorem, right, it guarantees that there is one triangle that has this measurement, right? Okay, because it's triangle congruent, right? If we make another triangle, if we think about talking about another triangle that has these same measurements, it will be the exact same thing. And so in other words, we're guaranteed a unique triangle here because we have this triangle congruence theorem. We only have one that could fit these measurements. Okay, there's only one kind of triangle that has these specific measurements. Okay, so now we have to figure out the remaining pieces though. Okay, so what I would recommend that you do in a situation like this, okay, is you need to start with, well, let's set this up kind of like willy-nilly here, right? Let's just say, all right, sine of 40 degrees over little a equals sine of 97 degrees over little c. Okay, using our like law of sines there, right? This is true, right? According to the law of sines, since angle A is 40 degrees, I could say sine of 40 degrees over the opposite side, little a here, and I'll go ahead and maybe label that as little a, right? And then opposite side here, little c. That relationship should be in the same ratio, okay, as sine of 97 over c. But of course, is this proportion, is this instance of the law of sines is going to be helpful to use this particular instance here? Okay, so why isn't it helpful? What's the problem with this setup that we've got? What's that, Ali?
There's the two unknowns. Two
unknowns, right? We have one equation. Two unknowns, one equation. So this is not helpful, right? So you want to be careful. You want to be strategic about how you select. I'll say two unknowns. You want to be strategic about how you set up your ratios, right? Don't just randomly select an angle on opposite side here. So how can we kind of work here? Well, I would suggest start with an angle / opposite side pair. Okay, maybe it's better to say a known angle and opposite side pair. Okay, start with a known angle and opposite side pair here. So in other words, what's a known pair of angle and opposite sides? The B, right? Angle B and side B. And so we want to start off with then sine of 43 over 22. And by the way, for whatever reason, I normally do sine over the side, but you don't have to do it that way. That's just the way I always do it for whatever reason. So if you want to do 22 over sine of 43, that's fine too. Just make sure you flip the other ratio. Okay? And then we will also need to set up to find another missing piece here. Okay? And so we're going to go for the next biggest one here. I like to do that. So sine of 97 over, and then little c there. Okay, so solve for the next biggest side. We'll do that. Okay, so how should we then go about solving for c here? Getting the c by itself, what should we do? I think cross multiplying is not a bad idea, so we'll say c times the sine of 43 degrees equals 22 times the sine of 97 degrees. And so then we'll divide both sides by sine of 43, so we get c equals precisely 22 sine of 97 degrees over sine of 43 degrees. So there's our precise answer, right? But of course we want to get a little more simplified than that. So we'll type this into our calculators. Okay. What mode should we be in? Degrees. Degrees. That's right. Yes. Wait, water, right?
I'll think about it.
Okay. But most likely.
Probably. 50-50 at the moment.
Then yes.
Okay.
Okay, please do make sure you can type this into your calculator correctly. I know it's kind of like, Mr. Wood, really? You want us to like type this in even though you get us the answer up here on the board? Yes, I do, because students make errors typing this in their calculator. For example, some people in here, the way they type it in, they might get 13.47. Okay. If you type this in and you get 13.475, you forgot to close parentheses. Okay? Make sure you do that.
What version do you have on your calculator?
What version do I have?
Yeah, what version of the calculator?
284 Plus. Silver Edition.
Because, like, for ours, we don't have to close for parentheses. Oh, wait, never mind. We didn't do the full thing. I didn't.
I did piece by piece. That's fine. Okay? Everyone's able to get 32.018? Yes. Okay. Very good. All right. All right. Is this supposed to be in degrees? Is this 32.018 degrees? No, right? It's side C. So it's a side C here. So it's going to go right here. I'm going to put a little squiggly equals 32.018. Okay? I use 3 decimal places, mostly out of just habit from teaching calculus. You know, you can kind of round to whatever the directions specify, or tenths place if you like to, or 100th, that's fine. But I'm just used to calculus, so that's just old habits, you know, kind of thing. All right. So now we can solve for our final side, and oh, well, look, we've got 1, 2 sides, and so we can use Pythagorean theorem, right? A squared plus b squared equals c squared to find the missing side. What? Why not? I have 2 sides. Oh, it's not a right triangle. Right, it's not a right triangle, so don't use Pythagorean theorem here. Okay? So we have to set up another ratio, right? Recommendation, don't use the information you calculated here. So don't use sine 97 over 32.018. Can you? Yeah, you know, if you really are feeling good about it. But if you made an error here, you're going to carry that error through when you solve for A. So instead, let's just stick with that sine of 43 over 22 equals, and now we'll do sine of 40 over A. And so we get then A is going to be 22 sine of 40 over sine of 43 degrees. Okay, like a so. Okay, and I get A is about 20.735. Okay. And so I'll put that up here. Okay. Now, does this answer make sense too? So let's also just check it out here. Again, remembering back to geometry. All right. Opposite the smallest angle should be the smallest side. Is that the case here? Mm-hmm. Yes. Opposite the middle-sized angle, the middle-sized side, and opposite the biggest angle, the biggest side. So, okay. Looking good, right? It looks like it matches up correctly. All right. Questions on any of that? No? Okay. Let's have you all try one then here. Excuse me. So you guys can try. This one right here. Let's say, so we'll just say for this direction, solve the triangle. Okay, which means find all sides and angles, right? Okay, so go ahead and find those missing parts. Still did. Eventually. I haven't figured out yet what I'm going to do. It's kind of interesting, though. It's like kind of nice. Having fun.
It is kind of nice.
It's kind of nice. So I'm going to email. So I'm recording using a program on the computer simultaneously.
Is it gonna like?
We'll see. We will see.
Hi guys.
If you need to, I'd call you for a set or something like that.
Okay. We can make them work.
Yeah.
After AP test.
Yes.
Where would it hurt?
At the place where it was cut off.
On your leg. That's your leg. Your leg is cut off. So how do you feel?
Haven't you heard though? People that are like lose limbs, they still feel phantom pains. Like the limb's still there, they feel pain.
I looked at an name for one.
Yeah. So that's kind of scary.
Oh, that's right. What days are tests?
What test?
Next week.
It's Thursday.
I'm not gonna be there. Wait, maybe.
Because of the AP?
Job test.
Yeah. Well,
At 7:30.
I understand. You don't have to. I mean, you'll probably be done. But again, yeah. So, but you don't have to. You're not. You also don't have to come. I believe, right? You're excused. But I mean, you're gonna have to get eventually. So.
Yeah.
You should just come anyway because you're
And
I
I
know.
did actually last. But if I do bad and I cry, then
Oh my god.
Question?
I was gonna say, for the test, I've taken all Wednesday, because I'll be here Thursday.
Yeah. Like Wednesday, the day before. You mean Wednesday? That should be fine. I think. Yeah.
Since we're only doing review.
Right. Yes, very good. Okay, so let's go to Parker. Parker, can you give us a piece of information here for solving this?
Well, you gotta figure out the third angle,
Okay.
and the third angle is 120 degrees.
120 degrees. Okay, and again, that's just the 180, right? Minus 32, minus 28. You get 120 degrees there. Okay, very good. You want to give us another piece of information here?
So then you know the sine of 120 degrees over 25 equals sine 32 degrees over the side length of lowercase c.
Oops. Yeah, you're right. Sorry about that. C. Yep. I started doing 28. That was wrong. So, yep, we'll find little c there. And then you cross multiply and solve, right?
Yeah.
Do some work. I'm going to put dot, dot, dot there. I think we can all cross multiply, hopefully, and solve, right? So we get c equals then
25 sine 32 over sine 120.
okay, good. I like that precise answer. And then what's the decimal approximation there?
15.30.
30?
hundredths.
Okay, that's fine. So about 15.30 there. Okay. Thank you, Parker. Let's try give someone else a try here. That was well done, though. All right, how about Gabby? Gabby, you got the last side for us there, side little b?
13.552.
Okay, about 13.552. Okay, and can you just give us your setup there for that? What did you do?
I did sine of 120 over 25 is equal to sine of 28 over b. And then I got b is equal to 25 sine 28 over sine 120.
Okay. Okay, sounds good. Which then gives you that approximate 13.552. Okay. Oops, I'm off the screen. There we go. So, yeah, questions on that? All right, pretty good. Now, let me do one more here, law of sines problem with us. Okay. So, again, we're going to solve the triangle. Okay. Given measure of angle C is 108 degrees, little c, side C, 56 meters, and little b, side B, is 27 meters. Okay, so I'm going to draw a quick sketch of this. Since I know angle C is going to be 108, that means it's obtuse. So I'm going to try and draw like an obtuse angle in here. Okay, something like that. Label that 108, and I'll call that angle C. Okay. Which means little c, side C, is 56. Okay. See, Kyle, homework we posted to Google Class. Okay. Okay, so side C has got to be opposite the angle C there, so we say it's 56. And then as far as angle A or B doesn't really matter, I'll say there's A and there's B, just because you could flip them around if you wanted to. And then since we've got little b is 27, opposite angle B, we'll put that 27 right there. Okay. Okay, now, what triangle congruence theorem do we have here? Angle side side.
We can't do that one.
Right, that's not a triangle congruence, is it? So, this scenario, okay, can lead to some interesting results. Okay, for our purposes for this class, all right, we're going to mainly focus on the one result. Okay, so there are actually three results that can three different conclusions we can arrive at given this information. earlier, right, for this one, since it was side angle side, there's only one triangle that's going to fit that information because it's a triangle congruence, right? Any triangle that has these three pieces of information must also have these three pieces of information too because, again, it's a triangle congruence. This is not a congruence, and so therefore it does not guarantee a single unique triangle here. In fact, this could create a situation where there is no triangle. So, for example, you can set up a scenario with this information, an angle side-side or side-side angle, however you want to say it. You can set up a triangle scenario where no such triangle would exist. Okay. You can also set up a scenario where two triangles could exist given this information. All right. So, like, where does that arise, or how do we determine if that's the case or not? Well, we're going to start like we normally do with law of sines by starting with our opposite side and opposite angle that we know. So that's going to be the c's in this case. So we'll say sine of 108 over 56 equals, and then in this case, we don't really have a lot of choice, right? In the past, right, we could find the missing angle, right? We can't find any missing angles here just yet. We have some work to do still. So sine of 108 over 56 is going to equal, and then what's the other ratio we have to use here? Sine of what? It's got to be b. Why? Because we know the corresponding exactly opposite side there. Oops, 27. I almost started to write little b there. Exactly. We wouldn't want to use a. We don't know angle A or side A, so that's not going to be helpful. We have two unknowns. Okay, capital A is different than lowercase a, so it's two unknowns. Okay. So to solve this, what should be our next step here to continue solving, continue working? Multiply both sides by 27, right? So we'll have 27 sine of 108 degrees over 56 equals sine of b. And then how should we solve from here? Arc sine. Oh, Mr. Witt, inverse trig. I thought we were away from that, but we're not. We're going to do arc sine here of both sides. And so we end up with the arc sine of 27 times the sine of 108 over 56. That's the precise answer, of course, right? But then we'll go into our calculators and type this in. So 27 sine of 108 divided by 56. So, okay, we get this ratio right there. Okay, 27 sine of 108 over 56. And I'm going to do arc sine, so second sine of that answer. Okay. The answer command is second negative button, by the way. So it's like the negative button, press second and then negative, you get the answer command. Right? And so we get like 27.293. 27.293. Okay. So angle B, we can say here is approximately 27.293. All right. So again, we're trying to figure out sine of what angle here gives us this positive ratio of approximately 0.458. Okay, so we're solving an equation here, and we get this, 27.293. Okay, which is an angle in what quadrant? 27.293 is in what quadrant? Quadrant 1, right? First quadrant. Okay, now, sine of this angle is going to be a positive ratio. What other quadrant is sine positive? The second quadrant. So there could be another angle here that when you take the sine of it, you get this value. Okay, and that's going to be 180 minus 27.293. Okay, the corresponding angle from the first quadrant, you find its corresponding angle in the second quadrant by doing 180 minus that 27.293. Okay, and you get 152.707. Okay, so is 152.707 a possible angle inside of a triangle? Inside of a generic triangle, yes, right? 152.707 is a possible angle in a triangle. But in our triangle specifically, will this angle work? No. So how many triangles exist given this information? Just one. Okay, just one. The one where angle B is 27.293. There could be other scenarios where both of these angles work. Okay, given the information that you have, both could work, which would then create two possible triangles you could have. One where angle B is this, 27.293. One where angle B would be this other angle, whatever it is, the supplement to the 27.293. Okay, it is possible. That's how you get that those two triangle possibilities. Okay, this is known as the ambiguous case of the law of sines. Question, Ramike?
Do we always do like 28 minus the angle?
For when we're doing law of sines, yep. And if you were given an angle side scenario or side angle senorio, you would want to subtract. Okay, yeah. Okay, but again, for like most of the ones we're going to be doing Ramike, we're going to focus just on the single case scenario. But this is honors, and you guys are capable, so I wanted to show you at least how this happens. Okay, how does a no triangle scenario occur? Well, what would happen here is if you end up taking arc sine and you get an error here, you might get an error. Okay, so like for example, just the information might be impossible, and when you go and take the arc sine, it's going to say error domain, like this number is going to be too big or too small. The ratio would be. So that would then there'll be no triangle. Okay, so 3 different cases for when you have this angle side or side angle information. We're going to be mostly seeing just the one triangle scenario, but just understand that there are multiple cases here. Okay. So anyway, from that point, now that we know our angle is 27.293, solving from here is pretty straightforward, right? We could now subtract these two from 180 to get that missing angle, and then do sine of 108 over sine of 56, and so on and so forth. So I think we get 44.707 when you subtract from 180 there, and so then you can do sine of 108 over 56 equals sine of 44.707 over, and then little a, and then cross multiply and solve. And a will be approximately 41.422. Okay? You guys, I can trust you can do those calculations. I don't want to spend our time on those. Okay? But I just want to kind of introduce that idea there. Okay? So again, my focus here was just to show you that the ambiguous case is a thing, but I'm not too worried about you running across it. We're going to focus mostly on the just normal law of sine stuff. Okay? Questions on any of that? All right. So then I want to really quickly then introduce the law of cosines. All right, we'll look at that real quick also. I just want to introduce it, though, and then maybe I'll do like one problem, and then I'll get you guys started on your assignment there. Okay? Yeah. Okay. Okay. Law of cosines. So, we're going to use law of cosines. Well, let's go back maybe for the law of sine stuff. Okay, for law of sines, we're going to be using that for angle side angle triangles and angle side triangles, okay, where we have that kind of information. For law of cosines, those are going to be for our side and side angle side triangles. Okay, and then of course there was hypotenuse leg, but that's right triangles, and you can just use regular trigonometry for those, right? So, law of cosines are helpful for this. Okay, here are our formulations for the law of cosines. Okay, you'll notice, what does this look like? Pythagorean theorem with a little correction factor for the idea that this is not a right triangle. Okay, so c squared equals a squared plus b squared minus 2ab cosine c. And then, of course, there are two other versions with b squared here and a squared here. Okay, and it's just a matter of like shuffling around the variables. So if I put b squared here, instead of a b, what's going to go there instead? C. So it's going to be a squared plus c squared minus 2ac cosine capital B. Okay, so it just shuffles the variables around, accordingly. All right. a squared then? Well, the a squared will be replaced with a b squared plus c squared minus 2bc cosine capital A. And I'll draw a little triangle here just so you can kind of like like that. Okay. So we'll do one here real quick, and then I'll cut you loose on some of the homework and stuff like that. Okay. We'll do more law of cosines tomorrow, but I just wanted to introduce the formulas, and then we'll just show you here. So solve for side A here. Let's say that. So we're going to solve for little a, and given this information. Okay, this is not drawn to scale because it looks more like a right angle than a 45-degree angle, but you get the idea. Okay.
Can you slide up?
Like this way?
No,
This way. Okay. Sorry, sometimes say slide up, and sometimes students say slide up, and they mean to see the top. So that's all. All right. So do we see, first of all, the directions here, notice, do not specify, use law of sines, use law of cosines. So part of the challenge of these problems is going to be you discerning what method to use to solve this triangle. Now, is law of sines even an option for us here? Why not?
Because cosine for notes.
Because we're in law of cosines for notes? Okay, true. But like in the wild, why?
The law of sines, both of the criteria is that they have two angles.
That we know, yeah. So we need to, right, they match for like the angle side and angle side angle, right? The first step when we set up a law of sines, do you want to say something?
There's no pairs.
Right, there's no opposite angle side or opposite angle or side pair, right? We have one angle, 45 degrees. We don't know its opposite side. We have 19, but we don't know angle C, nor could we find it out, right, with using law of sines. And then we have 46, we don't have opposite angle B there. And so, yeah, law of sines is just not an option, okay? So the good news is, right, you can kind of like process and eliminate down, okay? If you have an angle and opposite side pair, use law of sines. Or if you can find an angle and opposite side pair, use law of sines. If you don't have an angle and opposite side pair, nor can you get one, okay, then you have to use law of cosines here, right? That's on the option we've got. So, since we're trying to solve for little a, which formulation of the law of cosines do you think we should maybe use here? Which one would make the most sense? If we're trying to find little a, which one do you think would make the most sense to solve for, to use to get little a? Well, let's go through it here. So if I want to use the first one, do I have little c? Yes. Do I have little a? No, but that's okay. We're going to solve for it. Do I have little b? I do, 46. Do I have little a? No, but again, we'll solve for it. Do I have little b? Yes. Do I have capital C? Oh, so do we want to use this formula? No, because we have two unknowns, a and c. So we want the last one, right? We want the last one because the last one's got a little a squared here. That's what we're solving for. We've got b, we've got c, we've got b, we've got c, we've got capital A. So we want to use this formulation of it, okay? So we'll say a squared equals our b, which is 46 squared, plus the c, which is 19 squared, minus 2 times 46 times 19 cosine, okay, of angle A, which is 45. Okay. Now this one we can technically do without a calculator. Technically. What's cosine of 45 degrees? Right, same as pi over 4. So what's the ratio? Root 2 over 2. So we could like put a root 2 over 2 here and then kind of multiply it all out. Granted, it's going to be a little yucky, but you get the idea. Okay. Some people are like, nah, let's not do that. Okay, we won't. We'll use the calculators here. You got to be careful about how you type this into your calculators. Okay, watch your order of operations specifically. Okay, students mess this up every year without fail. They mess it up, and I guess I kind of get it. There's a lot of like operations going on here. So, for example, one thing I'll see students do, they'll do like, okay, 46 squared plus 19 squared minus 2 times 46 times 19. Okay, 729 times cosine 45. There's my answer. What's wrong with that?
You have to multiply the cosine by the 24619 before you can minus it.
Right, exactly, right? I mean, this is all one product. So don't like do this mess and then multiply it by cosine 45. It's not like parentheses, this whole quantity times cosine 45. It's this product times cosine 45. So if you're going to type it in, just type it in all at once. 46 squared plus 19 squared minus 2 times 46 times 19 times cosine 45. Okay, 1,240. So is that my answer?
No.
What is that?
Squared.
That's a squared, right? Remember, it's a squared equals this. So a squared equals, approximately 1,240.977. Okay? And then what should we do from here? Square root, right? Now, I'm in an equation setting. So should I put a plus or minus here? Plus or minus 35.227? Why shouldn't I? Right, it wouldn't make sense in the context here. We're talking about a triangle. It doesn't make sense for a triangle to have a negative side length. So we'll keep it positive, 35.228. I'll round it up to. And there's our missing side. All right, at this point, do I need to keep using law of cosines? What can we use now? Law of sines, because we have an angle and opposite side pair that we know, and so we can then solve for the remaining pieces. Okay? I'll say that. Solve for remaining. I'm not going to have us actually do that. I'm just going to say for your notes here. Solve for remaining pieces. Start with biggest side / angle. Okay, so in other words, the next angle we should solve for would be what? B, because it's going to be bigger than angle C, right? Because it's opposite 46 there. Okay, so in other words, angle B. And then once you have angle B, you can find angle C by subtracting from 180. Okay? Questions on any of that? All right, so I highly recommend you crack those books open, get started here, get some practice in with this, okay, because it's a little tricky. Just make sure that you got this down, all right, while you have me here to help. Page 434, numbers 5, 9, 21, 25, 45, and this is all calculator active, CA. Okay, so 5 problems. Okay, calculator active.
Do you want our quizzes? Like,
I will.
no, wait. Like and subscribe. Don't forget to make a comment. What's your favorite color? I'm going to start 10. All right.